All right, guys, it's Kene once again. Now, today, there is this problem we're going to solve using Python. It has to do with prime numbers, right? So let's look at the questions together. I'll share my screen, just a moment. Right, so here, guys, write a Python program that accepts an integer value and lists out the prime numbers from 0 to that number, the number inclusive. Can we think about it for a second? So if I have 10, the question is get all the prime numbers from 2 to 10, if 10 is a prime number. So think about it. How do we do it? What is a prime number? A prime number is one that is divisible by just itself and 1, leaving no remainders. So if I take 8, for instance, I know that 8 divided by 8 leaves no remainder. So I'll just say remainder 0. And 8 divided by 1 leaves a remainder of 0. Okay. Now these two the 2, 8 and 1 should divide 8 perfectly. But those are not just the numbers that can divide 8 without remainders. If I add 8 divided by 2, I see that there's also a remainder of 0. So that doesn't satisfy the condition for saying that something is a prime number. 8 divided by 2 leaves a remainder. For that, 8 is not a prime number. What if I had, say, 13? So I can't think of any number that divides 13 without leaving a remainder. I can't think of. So let's look at 13 divided by 2, that's 6, remainder 1. If I take 3, that's 4, remainder 1. So there's always a remainder. The only two numbers that wouldn't give us a remainder are 13 itself and 1. So that's why 13 is a prime number. Right, enough of the talk now. Okay, so now let's look at the question again. It says list all of them. So if a user gives, say, 100, and the question is get all the prime numbers from 2 to 100, how do I do that? So I think that what I can do is I'll take 2, right? Then I'll check if 2 is a prime number. If it is, I'll collect it. I'll take 3, check if 3 is a prime number, collect it in a bucket like a list. Then I'll take 4, check if 4 is a prime number, I'll collect it. And if it is not, I'll just jettison the number, just do away with it. That's what I will keep doing until I get to 100. So we've seen it now, right? Now, so let's say I have taken 100 and somewhere along the line, I want to check now, in counting from 2 to 100, I have 8. And I want to check if this 8 is a prime number. How do I do it? Because that's the point we're going to start from. We're going to take a number and check whether that number is prime or not. So it's going to be progressive. We'll check first if one number is prime or not. Then we can now proceed from there using that same principle to now get all the numbers, all the prime numbers up to a certain level. So if I take 8 now, the user has given us 100, get all the prime numbers from 2 to 100. But at some point I have 8. I want to check now if 8 is a prime number. Remember that I'm just going to take the 8 and divide 8 by all the numbers up to 8. See if any will give us a remainder from 2 to 7. So I would try to, if there is a remainder, That means we're on track in ascertaining if it's a prime or not. 3, there's a remainder, still a prime. 4, oh, let me take 2 out. Definitely, once I use 2, 8 divided by 2 gives us a remainder of 0. So 2 should not leave a remainder ordinarily, right? But it has a remainder after that division. That means that 8 is not a prime number. What about 7? Let's say there's a number 7. So I'll use 2. 7 divided by 2, there's a remainder. I'll take 3. 7 divided by 3, there's a remainder. I'll take 4. 7 divided by 4, there's a remainder. 5. 7 divided by 5, there's a remainder. That's remainder of 2. 6, finally. 7 divided by 6, there's a remainder of 1. So you see, guys, I'm not going to use 1 in the division, and I'm not going to use 7. I'm going to use all the numbers from 2 to the number just before that particular number, which is 7 here. So 6 is the largest number before you get to 7, right? So we see that we tried dividing with all these numbers and we got remainders. That means that 7 is a prime number. That's the thinking. Do you understand? So I'm going to define a function that will just tell us true or false. It will tell us if a number is prime or not. That is true or false. Okay, so let me start right away. I'm going to get the input from the user. So input, using the input method, I would say enter an integer value, right? Enter a number. Then I would convert that number to that string. You know, when you get an input from the user, it's in form of a string, even though it's a number. So I need to convert that to an actual integer. So I'll use the int method there and simply just have this as the argument, whatever was entered by the user. Right. So that's it. The next thing now, guys, is to create the function. So I'll define a function, check prime, right? Okay. Then I will get, it's going to take one argument, which is that number that I want to check if it is prime. So I'll just say, just give it a value of v, which is like val, right? Then let me just say val anyway. Val number, value of the number. Then I should now use a while loop. So I get the number. I'll loop through from 2 to the largest number before the number that I'm checking, right? So I'm going to create something like a count variable, a count variable. I'll set it to 2 because I want the first divisor to be 2. Then there should be a way of telling the user, like knowing if something is prime or not, like a flag. So I'm going to create that variable. I'll just call it flag it, and I will set it to true, which means we're starting out assuming that the number is prime. Okay. Then I'll create a while loop. While that count variable is less than val num. You know, I don't need to check the number. I don't need to divide the number by itself. That's why it is less than the number itself. So I will do this. is less than val num, which actually should be yeah, okay, so we've got it from the user. So less than val num, and then I will do what I need to do. So yeah, guys, we don't have val num yet. You know that this val num is the parameter for this function. We are going to provide that later. So I think I should just bring this from here to this point below. All right. Okay. So while is less than, I should do something. So I'm going to introduce us again to something. I've talked about it, in previous videos. It's the modulus operator. We use it to check what the remainder is after a division operation. So if I have 5 divided by 2, which is like what's the modulus this thing return? What does it return? A remainder of 1. 5 divided by 2. So 5 modulus 2 will give us 1 because we're interested in what is remaining. And that modulus sign is modulus operator is the percentage symbol. So let's say count var, val num modulus count var. If it is. Now, if the remainder is 0, we should break. I'm starting from 2 and I'm counting up to the point just before the number. Okay. So there has to be a way of increasing this my count variable. So for every round, it should increase by 1 so that I can get to the number just before the number supplied. So if I'm supplied 7, I need to go from 2 to 3 to 4 up to 6. So that's what this count var represents. That's a count variable. So there has to be a way of increasing it by 1 for every round. That means I'm going to simply say count var is equal to the current value of count var plus 1, right? All right, but yeah, this is one way to do it. But why don't I just say count var plus equal 1? That's the same thing as what I did last time. All right. Okay, so guys, that's it. Then I need to now, once I get a remainder of 0, that means the division was perfect. No remainder. That means that number, the file number, there is not a prime number. So I need to change the flag it status from true to false. So I'll set it to false now. Flag it becomes false because it's no longer prime. Then it breaks out of this. It ends the cycle immediately. Once it finds, there's no need getting to. So if I see, let's say I have 7, I have 9. Then I get to 3. I see that, 9 divided by 3 does not give a remainder. At that point, I already know that 9 is not a prime number. So why divide by 4 and divide by 5 and divide by 6? That's just a waste of resources. So we need to just quickly come out of that loop. And that's the use of this break, right? Okay, so guys, having come out of that loop, I need to now check if flag it is true, that means it is prime. Simply return flag it. That's it. I'm going to return. Using the return statement, it will bring something to us or to the user. So if flag it is true. Now again, I don't want to use something lengthy, just if flag it, then return true or return flag it. Okay, so that's it. If flag it is true, then return it. Give us the true. So once I call check prime, it will give us true or false. So let me just use else really to get the other one if it is not. Else return false. Return false. Let me change this to true. Yeah. Okay, so that's it. Now, guys, I should run my program. So user puts in a value. I convert the value to an integer. Then I'll call my check prime. Check prime. It takes one argument, and that's the number given by the user. And I'm going to print it because it's going to return true or false. So I need to print the true or false. Okay, so I run the program, enter a value, I'll say 8. Name val num is not defined. What could be the problem there? Val num is not defined. Okay, so it's telling us that this is not recognized. Oh, so I should val num. I spelled that wrongly. Val num, guys, not val num. Val num. Okay, so 8. False. 8 is not a prime number. We know that. Let me try 19. I'm sure that 19 is a prime number and see what it tells us. 19. True. Yeah. So that's it, guys. The first part of the question, we've answered the first part, which is just tell us if this number is prime or not. The next step now is to still use this function, which checks an individual number. I'm going to use that function, and I will go through the numbers up to the maximum. So if I'm asked to get all the prime numbers from 2 to 100, okay, I'll take 2, run this function for 2, tells us if it is true or false. If it is true, collect the 2. Then I'll go to 3, run this same check prime. If it is true, I'll collect the 3. I'll go to 4, run this same check prime. So I'll be checking, still running this same function for every number going from 2 to, say, 100. That's the next part. Okay, so guys, let me proceed. Now this time, it's what the user is going to put in now will be the end point. We're not checking if that number is prime, if the number inputted is prime or not. We are checking, we're getting all the prime numbers up to whatever the user puts in here. So if the user puts in 100, we're getting all the prime numbers from 2 to 100. So there's a change there. So I'll just say get all primes up to okay, so just like that, get all primes up to, the user will just give us an integer. That should be it. Right. Then the next thing I'm going to do now, I have this function that is going to check just one number, tell us if it's prime or not by saying true or false. Okay. I'm going to now go through all the numbers. So I'm going to create another function that contains a loop. So this other function, an outer function now, within which I'm going to put this check prime. So it will take, I have, say the user put in 100. So it check 2, check if 2 is prime. If it is, collect it, check if 3 is a prime. So that's what I want to do now, create that loop that will run through all the numbers from 2 to 100. I'm going to use a for loop. For, yeah, I need to put it in a function. Define the function all primes. This time I'll call it all primes. And it will take one parameter, one argument, sorry. Argument, parameter, that placeholder within the parentheses of a method, that's what you call the parameter. But the actual value when you are calling the function is called the argument. So, but sometimes, we just use the two interchangeably. Okay, so I'm going to supply one parameter there, which is n. Let me call it n. That is the number. Then I will run a for loop within it. But before then, let me create a list. Prime list. So that will be like the buckets with which I'll collect the prime numbers. For x, in this, I'm going to have a range in 2 to whatever the user puts in 100. I need to check the 100 itself if it is a prime. So in range, I have to add 1 to it. So 100. No, I need to use a dynamic stuff. So that will simply just be n plus 1. Okay. Because if you don't put that plus 1, it will stop at the number just before the number you supplied or the user supplied. So those are the strange things with programming with Python. Yeah, because that's just what it is. It's strange, right? If you need to do something with a number in the loop, then you need to add 1 so that it doesn't stop just before the number. So for x in range 2 to n plus 1, what should I do? I will call this function. So you see that x stands for the 2 or 3 or 4 up to 100. So those are the actual numbers I want to check. I need to know whether they are prime numbers or not. So I'm going to call check prime within this other method and in this loop. Check prime. Now the argument, this number that I want to check now, I want to know if it's a prime or not. So check prime like that. So if it is, this check prime returns true or false. So the next thing I'll just do is if what I get. So if check prime, which is going to come as true or false, it will return to us as true or false. If check prime, giving this argument x. So if it is true, right? So just take this off. I use this to explain. If it is true, then do something. Collect it in prime list. Prime list dot append. So I'll just append the x. So I know that yes, it is prime. That's how I'll collect all the primes. Right. So after that, Hope nothing else. I'll just return. I'll return the prime list. Return prime list. So this second function will return the prime list that we have got. Okay, right. Now let's get on with it now. The norm. So I'm going to call all primes here, guys, not the inner function, the outer one, all primes, and that is from 2 to say 100. Okay, so let's see. Run, get all primes up to 101. Yeah, so that's successful. 2, 3, 5, 7, 11, blah, blah, blah. So these are all prime numbers up to 101. You know, we added 1 to it so that the computer includes 101. Do you understand? Okay, so that's it. Yeah, what else can we do? I'm thinking, but I don't know how much time I have. I don't have much time. Well, in another video, we're just going to look at how to optimize this process. I mean, there's a lot of redundant operations here. I mean, why do I need to divide that number, right? When I can use the square root of the number. You know, if you have a number, say 18, or let's say 32. So you know, you have two factors really, 2 and 16, 4 and 8. Well, I'll do that in the next video. Let me just end this because of time. I hope you learned something, guys. Again, I'll leave this program on my website. You'll find it. I haven't put it yet, but I'm going to do that. www.thetutoraid.com.ng. The tutor. See, guys, tutor, Tutor, then aid.com.ng. That's the website. I'll leave this there. All right. Have a nice day, guys. Bye.